What is going on, you guys, and welcome back to the channel. In this video, we're going to be looking at the concept of data classes in Python, as they enable us to write super fast classes that are centered around storing more so a state rather than adding a lot of logic, which you'll see in a second. They can save you a lot of time from defining very typically tedious classes that we tend to do in Python, as well as just enhancing readability as well, as they're super clean to look at. But before we actually do any of that, let's first go ahead and define a typical Python class. And the thing to look out for is how tedious it can become when it comes to defining it. So let's go ahead and create a class that represents a student. We'll say that there's a first name, let's add some typing, say a last name, typing, and age. And then let's create our init function. We'll say first name, string, last name, string, and the age, which is an integer. And then we have to associate our attributes. So self.first name equals first name, self.last name equals last name, and self.age equals age. So already kind of felt a bit tedious, just a lot of repetition, a lot of boilerplate stuff that we're doing here. And then let's go ahead and create our first student. So we'll say student1 equals student, and we'll say Harry Potter, in quotes of course, and we'll give them the age of 9 or 18. So now if I go ahead and print this, so student1, we get back this rather ugly looking output, which is just student object along with the address, so nothing really helpful. But in order to kind of show the string representation, we have to go ahead and add a string method inside our class, so __ string. And here we can say that the return value for that would just be self.first name, self.last name. Now if I run this, we get back Harry Potter in the console, which is just down below for me, if you guys can see that. But the point isn't so much for me to show you that Python has this, so you can add like string representation inside your class. It's more so to show how tedious this becomes, as this is very standard, very boilerplate stuff. We shouldn't really be spending so much time having to worry about thinking about like the representation of it. It would be nice if something like this came out of the box. Now, another thing could be if we want to see whether two students are equal to each other. So if I define the exact same student, so Harry Potter age 18 for student 2, and if I then compared them, so if I said, does student 1 equal to student 2? In our heads, that makes sense. Both should be equal to each other. But if I run this, we get back false. So the computer doesn't see this student and this student as equal. To us, it does. I mean, at the end of the day, computers are here to serve us. So it would make sense for both of these two things to be equal. Now we can do that just by adding an __ equals function, self, and then other student. And we can say return, and we'll just say that both the students are the same if their first name and last name match up. So say self.first name equals other student dot first name, and self dot last name equals other student dot last name. Now if I run this, we get back true in the console because both Harry and Harry match up along with Potter and Potter. Again, I'd like to reiterate that I'm not here to show you that Python comes with all this fancy stuff, more so just the kind of tediousness of writing all of this and defining all of this, as we kind of want to write actual Python or like more interesting logic when it comes to our classes. Something like this takes up a lot of time and also a lot of space as well. As you can see, like we've taken up already quite a few lines. So this is where data classes come in handy, because the data class library that comes with Python sorts out a lot of the boilerplate stuff. And by that, I mean a lot of the methods that we've just outlined here. This can also include like the underscore representation method or the less than, greater than, all of these things. So in order to do that, we first need to import the data class library. So we'll say from data classes import data class. Let me just run this to make sure it's been imported properly. Okay. I'm just going to comment this line out, but let's go ahead now and define the exact same class, but using data classes. So to do that, you need to use the decorator data class. And then under that, you define your class. So we'll say student, and just to like not have lead to any confusion, we'll call the student data class, say first name, last name, and age. And that's it. So let's go ahead and do the same thing. We'll say student1 equals student data class. And we'll have the first name, let's change the name. We'll say Frodo, and then Baggins, give him the age of 30. Say student2 equals the exact same. All right, so first let's go ahead and see what happens when we just print out that object. So we'll say student1, hit run. We get back something like first name, last name, and age, but it's clearly defined. We can see more information about the object that we defined and also the way in which this class is built up. But now let's also see what it would be like if we compared both student1 and student2. So if we run this, we get back true, because what's happening under the hood is that it defines the equal function or equal method by saying, okay, does each attribute match up to the other one? So does first name match up to first name, last name to last name, age to age? We can, of course, override this by saying something like a student equals another student if just their first name matches up. So if I say something like self and then other, then return self dot first name equals other dot first name. If I run this, we should still get true. But if I change the surname of the last one, so we'll say Frodo Doe and then run, we still get true, because what we've done is just we've overridden the equals statement, which is really handy. I mean, sometimes you may want to do this and sometimes you may not. It becomes even more useful if you don't have to and you just want to leave it like that. So that's a fast kind of add-on that comes with data classes. As you can see, compared to our last one, we only used pretty much like 5 lines to define this data class, whereas in our last one, in our normal Python class, we defined a hell of a lot more. We defined the init, the string, and the equals. Here, we don't need to define the init as that is done for us. Okay, so the next thing is that it can be quite easy to convert a data class into a tuple or a dictionary. And to do that, all you have to do is import as tuple and as dict. And if we were to now print out student1 with that, so we'll say as tuple, just copy this and print it out as a dictionary, as dict. And this can become super useful if, for example, I don't know, you wanted to create like an API, a web API output from it. We can see here that the tuple output is the top one. The dictionary output is this one here. So first name, last name, Baggins, and age, sorry. And you can see how if you're someone who works, I don't know, in web development and you build APIs, something like this can be extremely useful rather than having to define a representation of a dictionary within this class. All of this is handled for you. So again, a lot of time saved there as well. Okay, the next thing is that you can also, if you have a object, let's say with student data class, and you put them inside a list, you can also define how they will be sorted. For example, let's go ahead and create a new data class, and we'll call this a product. So we'll say data class, say product. The first thing is we want a name of the product. We want a price. We'll just define this as a float. Let's not think too heavily about that. In stock. Actually, let's leave the in stock out for now. We'll come back to this. And then quantity. So now, if we want to, let's go ahead and just create a couple products. So we'll say apples, or apple equals product. Give it the name of apple. Give it the name of, give it the price of, let's just say 150, and the quantity of, let's say 10. Next, we'll say orange. Just create a couple of these. Orange, we'll say 160, and we'll say 20 here. And finally, let's just say chocolate. Product, call it chocolate, and we'll say that's 2, and we'll say the quantity of that is 15. Okay, so let's say our items equals a list of all of these. So we'll say apple, orange, and chocolate. If I go ahead and print this out now, so I'll say print items. Just before I do that, let me just comment the last ones out. Run this. So let me just shrink this a bit. You can see that, actually, let me zoom in. I think maybe the size could be a bit too small for you guys. Font size, just do large. Okay, so you can see that the items that we've added and their representation, so apple, orange, chocolate, along with their price and quantity. But let's say we wanted to sort this. So if I ran something like sort items, so if I did sorted like that and run it, we get back an error because the less than sign is not supported between the instance of product and product. Now what we can do is, of course, we can in a normal class we would define our less than parameters, or how to work out whether or not something is less than another. But with a data class, it becomes super easy. We can add this parameter to our data class decorator. We can say order equals true. The next thing is we have to tell the data class how to order by. So first of all, we need to add this sort index, which is going to be a float because we're going to order our products based on their price. And then we need to use this field function. And to do that, we have to import it from data class. We'll say field. And then down below, we can say field. And we'll say init equals false. And I'll explain what this means in a second, along with repr equals false. So REPR, like so. So what we're saying here is, okay, add another attribute, call it sort index. It'll be of the type float. And we don't want to initialize it. So for example, we don't want to, when we create our Apple object, for example, we don't want to define the sort index by passing in an argument or a parameter. And also when we print it out, don't show us the sort index, just leave it out. So now this isn't like the last thing. What we want to do is we need to add the logic behind our sort index inside our product data class. And to do that, as the init function has already been declared for us, there's something else called a post underscore init. And here is where all the logic around what happens after the init function is called. So we can say something like self dot sort underscore index equals self dot price, just like that. So now if I run this, we get back the sorted list. So Apple, which is the price of, actually, let me just, in order to, let me just put the chocolate at the top, as this has a lot, this is a bit more expensive. But you can see now that it's been sorted based on the price. So Apple comes first, then orange at 1.6 and chocolate at €2 or $2, however you want to say it. But it's super easy, it's super clean to do as well. Like we only had to define, we had to alter one line and add 3 others, which is our post init, along with how we sort our product. The other thing is we can also add another attribute. We can call this in stock, so whether or not it's there or not. And this could be an attribute that is defined based on the quantity attribute. So for example, this will be a Boolean. We'll say field, and we'll say init equals false, but we want to leave the representation because we kind of want to see whether or not it's in stock. And just down here, we can say self dot in stock equals self dot quantity is greater than 0. So if the amount or the quantity is greater than 0, then it's in stock. Otherwise, it's no longer in stock. So if I run this, we can see that because we defined we didn't add like a repr equals false, because by default repr equals true. It shows us in the in stock, or it shows us the value with each product. However, we don't have to initialize it, so we don't have to say something like true, false. Like it's a conditional attribute based on the attributes that are defined beforehand. So that's, again, another really neat trick that comes with data classes. The last thing I want to show you before we go ahead and finish up this video is that if you want to create a read-only object from a data class, for example, if you want to create like something like product, but you don't want it changed afterwards, you can set the argument of data class to frozen, and I'll show you that in a second. This means that this also means that you cannot use the post init function or method. Let's go ahead and do that. So I'm going to go ahead and create another data class, and here we need to add the argument of frozen, which is basically saying once you've created it, you cannot change the attributes. So say class invoice, and let's say we have a payer, which is a string. We have a payee string, and we can say an amount, which is float. Now, if I go ahead and define one, so I'll say invoice 1 equals invoice, and then payer we'll say is Harry Potter. You can see that I'm running out of names. I tend to just go with Harry Potter or Frodo Baggins. Payee is Frodo Baggins, and we'll say the amount is 100. So if I run this, everything should be working smoothly, and no, it's not, because I added a comma. Now if I run this again, and yeah, positional argument, typical amount, run, everything works smoothly. Actually, let me just remove that print there. But now if I try to change one of the values, so if I say invoice 1.payer equals John Doe, if I run this, we get back cannot assign field payer as the class is frozen. So this can also be extremely useful if you want to create only read-only objects that cannot be altered. For For example, something that's based around an invoice, these are things that in real life we wouldn't want to alter. But that pretty much sums up the video for today. I hope you guys got a good idea on the concept of data classes, as they can be extremely useful. It can shed so much time when it comes to defining very tedious logic and functionality around a typical Python class. Definitely recommend employing these concepts into your day-to-day Python life where possible. Otherwise, I just want to give a big shout out to Gio, who's been a very helpful member on the Rhythmic Discord server. If you guys want to join on, please feel free to. The link will be in the description below. Otherwise, stay healthy, stay safe, and have an amazing day.